talking about inequalities, we also need to talk about compound inequalities. A compound inequality is any inequality that represents one situation, therefore we use one graph, but it's made up of more than one inequality symbol. Or it might be two separate inequalities, but it contains the words either and or. With and or, we solve each inequality separately, but we graph them together because, again, they are representing one situation. So if I look at example 1, I have 4y minus 2 is greater than or equal to 14, or 3y minus 4 is less than negative 13. So when I solve for my region of y values, they're going to work for either one of those inequalities. So I'm going to solve each one separately. So I'm going to solve the left one first by adding 2 to each side of the inequality symbol. And I get 4y is greater than or equal to 16. I divide by 4. And I get y is greater than or equal to 4. Or, solving the other one by adding 4, 3y is less than negative 9. Dividing by 3. So y is less than, whoops, not or equal to, just less than. Y is less than negative 3. So I end up with the sentence that y is greater than or equal to 4, or y is less than negative 3. So when I go to graph that, I need to make sure I have both 4 and negative 3 on my graph. So negative 3 might be down here somewhere. Maybe here's 0, and then 4 is up here somewhere. So I can have y values greater than or equal to 4. So I'm going to put a closed circle at 4 and shade everything bigger than 4, since they can be greater than it. Y is less than negative 3, so I put an open circle at negative 3 and shade everything to the left of it to show that I can be less than negative 3. So there's my two situations. I'm looking at the next one. So I have 3x is greater than 3, or 9x is less than or equal to 54. Again, I'll solve each piece. So I'll say I solve this one by dividing by 3. I get x is greater than 1. Divide by 9. I get x is less than or equal to 6. So x either has to be bigger than 1 or less than or equal to 6. So make sure you can interpret what it means to be or. So here's 1, up here is 6. So x is greater than 1, so I put an open circle at 1 and shade everything greater than 1. Or x is less than or equal to, so I put a closed circle at 6. Less than or equal to 6, so everything less than that. And notice that when I shade that, it ends up crossing over 1 because it can be either or. It doesn't have to be both. It only has to satisfy one of those expressions. So either everything bigger than 1 or everything less than 6. So what ends up happening is that we get all real numbers for a solution. So any number I plug in is going to satisfy one of these inequalities or one of these equations. Okay, looking at what about when we have just one compound inequality? So instead of having two inequalities with the word in between, what if we just have one inequality? And it has 3 parts, for lack of a better word. What I want to make sure and do is do all 3 parts of the inequality. So anything I do to one part, I have to do the other parts as well. So think of it as having basically 2 equal signs. We have to balance it all out. So let's look at example 3 here. First thing I'm going to do is I want to get x by itself still. So now instead of getting x by itself on one side, I want to get x by itself in the middle. So I'll start by adding 3 to all 3 parts. I get negative 15 is less than 4x is less than or equal to negative 12. Dividing by 4. I get negative 15 fourths is less than x is less than or equal to negative 3. So when we have 3 parts, it's read as and. So if I look at each piece, so I see that x has to be less than or equal to negative 3 and x has to be greater than or equal to negative 14. So both things have to happen. So I like to leave things as fractions. I like when you leave things as fractions. However, for graphing purposes, sometimes it's easier to have things as a decimal or a mixed number. So I'm going to go ahead and say that this is the same thing as saying negative 3 And let's see, 15 divided by 4, doing a little scratch work quick, goes in there 3 times with a remainder of 3. So negative 3 3/4 is less than x, which is less than or equal to negative 3. So looking at my graph, let's say here's negative 4 and here's negative 3. I'll graph each piece individually. So here, instead of or though, it's and. So x has to be greater than negative 3 3/4 and it has to be less than or equal to negative 3. So I'm going to put an open circle at negative 3 3/4, probably right about here. X can be greater than that, but it also has to be less than or equal to negative 3. So here's my closed circle at negative 3, and so notice I fall right in the middle there. Those are all my possibilities. Looking at the next example, example 4. I'm going to go ahead and subtract 1, because again, now I want to get the variable by itself, so I'm going to try to get z by itself in the middle, and I'm going to get negative, oops, excuse me, not negative, 36 minus 1 is 35, is less than negative 5z, which is greater than negative 22. I'm going to divide each side by negative 5. When I do, I have to remember to flip my inequality. And I get negative 7 is greater than z is less than 22/5. So for me, it's really hard to read an inequality appropriately unless I put the smaller one first. And actually looking at this, I'm saying that z has to be less than negative 7 and it has to be less than 22/5. So, and I'm going to explain this in a minute. I'm going to write 22/5 as a mixed number again. So I'm going to say negative 7 is greater than z, but z is less than 5 goes into 22 4 times with 4 2/5. So look at again each piece individually. I wish I could just cover this all up. So if I'm looking just at this, the variable is always read first. So it's read z is less than negative 7. And again, I wish I could cover this up. Z is less than 4 2/5. Well, if z is less than 4 2/5, if z is less than negative 7, won't that mean that it's also less than 4 2/5? Because it has to satisfy both. So if I look at my graph, if here's negative 7 and here's 4 2/5, 0 is somewhere kind of, I guess it probably would have been a little bit closer to 4. If I have to be less than both of these, z is less than negative 7, z is less than 4 2/5. In order to be less than both of them, I'm going to have to be down here. So even though my inequality technically tells me to shade below the 4 2/5 and shade below the negative 7, if I shade in here, I will not be satisfying this part of my inequality. So I'm only going to put my open circle at negative 7 and shade just below negative 7. Looking at example 5. So these are some bigger concepts here. It's not as much just simply following steps. You really have to think about your solution set. So please make sure as you're taking notes on this video, you are making note of any questions you have to bring to class so I can clear up that confusion and talk a little bit more deeply one-on-one with you about that. Looking at the last example, again, I want to get x by itself, so it's in the middle. So I'm going to add 3, add 3, add 3. I get negative 15 is greater than 4x is greater than negative 12. I'm going to divide by 4. And I get negative 15 is over 4 is greater than x is greater than negative 3. So I'm going to write this so the smallest one is first because I think it's weird to talk in terms of greater than. I think it makes more sense to say that instead of saying x is less than negative 15 over 4 and x is greater than negative 3, I think it makes more sense to start with what x is greater than and then stop with what it's less than so I can see what I'm squishing it in between. So I'm going to go ahead and rewrite this as negative 3. I'm not flipping it, so it was pointing the smaller side at negative 3, so I'm turning it around, but it's still pointing at negative 3. Again, it's pointing at the x, so it's still pointing at the x. Negative 15 over 4, guess what? I've already done that. That's negative 3 3/4. Okay, so I go to make my graph. I'm going to have negative 3 3/4 here. And then negative 3 here. Negative 4 is probably somewhere about right here. Okay, and then I'm going to go ahead and read what this means. This is telling me that x has to be greater than negative 3, so out here, and it has to be less than negative 3/4 down here. Well, if I'm up here and up, I can't be in those two separate places. I can't be both bigger than -3 and less than -3/4 at the same time. That doesn't make sense. It's not giving me an area I have to stay between. It's giving me two separate regions. So for that reason, I'm going to go ahead for this one and say, I tried to graph it. I got this. Doesn't make sense. There is no solution. So again, if you need to go back and rewatch the video, please do, because once again, these are a little bit harder concepts to grasp. And also make sure you're bringing these questions in, mark on your notes, highlight on your notes, whatever it is that you need to get a little bit more clarification on in class.